Hi friends, today let us see what is recursion. The idea is to introduce you on recursion in C programming language. Now before we start on recursion, let us see how parameter passing occurs in C. For example, in this particular case, a function f is being called with a parameter 10, with an integer parameter 10. Now the way it occurs is when it calls a function f, right, it puts the parameter value 10 in the stack and also puts the return address in the stack, so that when the function completes, when it prints this particular string, it will actually return back to the return address as specified by this return address. So when you call a function f, 10 is being pushed into the stack, and also by virtue of the call instruction, the return address is also pushed into the stack. And after the end of the function, the return instruction, the RET instruction, will actually get back to this line, which is the return address which was stored in the stack. Now in a function f, if you accidentally call the same function f again, okay, we have a function f and we call the same function f, what is going to happen? Yes, it will go into infinite loop, that is nothing but recursion, and finally it will result in stack overflow. Now why do we call this as stack overflow? Let's see. The moment you call function f, it's again calling function f. Okay, so it will go to an infinite loop of calling function f, and each time by virtue of calling f, it's going to save the return address in the stack, and finally all the stack will be full of return addresses and finally run out of the boundary of the stack, that is overrun the stack, and resulting in a stack overflow. Is that clear? Okay. Let's write an example for recursion, a function that prints till 0. Say for example you specify a value of 3, then it should print 3 to 1 and it's 0 using recursion. So we are going to try to write this function using recursion. So here is the already pre-written function which says print till 0. So it's going to use recursion. So a recursion has to have a termination condition, otherwise it will result in an infinite loop, like the function that we saw earlier where f is being called and without any termination condition, f is being called again, so it resulted in stack overflow. Now in this particular, when you write any recursive function, you have a termination condition. So let's see what we need to do. So we have written this particular print till 0, and it has to print whatever the value n, okay, and n equal to n minus 1, we decrement n, and we call the same function print till 0. So until n equal to 0, if n equal to 0, we are returning back. So this function will return only when n becomes 0, that is print till 0. So let's say a value of 3 is specified. Is it 0? No. So it's going to print 3. N is going to be decremented with n equal to n minus 1. Okay, so n becomes 2. Again the same function is being called with value 2. Is it 0? No. So it's going to print 2, and again n is decremented. N is 1 now. So print till 0 with 1. Is it 0? No. So it's going to print 1, and finally n equal to 0. Now it's going to be called with the value of 0. Is it 0? Yes, and it's going to return. So in my main function, I'm actually printing calling this function print till 0 and passing a parameter of 5. So it's going to print, when I run it, I get a value of 5, 4, 3, 2, 1. Other classical example is calculation of factorial function. So factorial of 3 is 3 into 2 into 1, that is 6. Let us try to do it using recursion. Now here is the implementation of factorial. It uses the property that factorial 4 is equal to 4 into factorial 3. Okay, factorial 3 is equal to 3 into factorial of 2. So factorial n equal to n into factorial of n minus 1. Okay, so let's see how this works now. So my factorial n, and when n equal to 1, it returns 1. The termination condition is if n equal to 1, it will return back. Otherwise, it will continue to calculate the factorials. So fact equal to n into my factorial into n minus 1. So if 3 is being supplied, 3 into my factorial with a parameter 2. Now 2, is it 1? No. So factorial equal to 2 into factorial of 1, n minus 1, that is. And hence finally you get the value 6 in the case of 3. So here I have started a debugging session with my factorial being called with value of 5. So we are saying n equal to 5, and let us step through it. So is n equal to 1? No. It's going to do 5 into factorial of 4. So it's going to call again n minus 1 with, so now n equal to 4. So n equal to 4 into factorial of 3. So it's going to call again with factorial of 3. And finally we get the value. Let us do it again quickly. N is factorial is being called with the value of 5, n equal to 5, then n is called with 4, n is called with 3. When you actually do it, you can step through this. N is called with 2, n is called with 1, and this is the termination condition. What we see is the value 120. So hope you like this tutorial. If you need any specific tutorial, do write to me. Thanks.